Today, we have another chapter to be discussed and to be cited an example in ideal gas of thermodynamics and heat transfer. For our first problem, this is the part 1 of our problem. The temperature of 3 moles of a monoatomic ideal gas is reduced from its initial temperature 540 Kelvin to its final temperature 350 Kelvin by two different methods. In the first method, a 5,500 joules of heat flows into the gas, while the other method is 1,500 joules of heat flows into it. In each case, we are tasked to find for the change in the internal energy of the monoatomic ideal gas and the work done by the gas. Before jumping into the solution, we need to list for our given. So we are given 3 moles of monoatomic ideal gas. We have also the initial temperature and the final temperature. We are tasked to find for the change in the internal energy and for the work done by the gas. For our solution, since it is a monoatomic ideal gas, we have a formula here in finding for a change in internal energy to be 3/2 multiplied to the number of moles multiplied to the universal gas constant and the change in temperature. So let's proceed. So this is a simplified formula. So our change in internal energy is equivalent to 3/2 multiplied to 3 moles of monoatomic ideal gas multiplied to the universal gas constant in this unit, joules per mole Kelvin, that is 8.3145, multiplied to the difference between the final and the initial temperature of our ideal gas. So after calculating, we now have the change in the internal energy of the ideal gas to be negative 7,100 joules. So we have a negative 7,100 joules. Next, let's proceed in finding for the work done by the gas. So the work done by the gas, and there's the problem, it is stated that there are two methods. First, on our first method, we have a 5,500 joules of heat that flows into the gas. So this is the solution. So we know that the formula for the work is equivalent to the difference of the heat, whether it is added or reduced, or minus the change in the internal energy. Since we already have the result of our change in internal energy to be 7,100 joules, we're just now going to plug it in here. So this is positive since our internal energy is negative, minus positive, it would be 12,600 joules. The work done by the gas in our first method is 12,600 joules. While on the other hand, we have 1,500 joules of heat flows into the ideal gas. So this is the solution. The second method, the 1,500 joules of gas plus our change in internal energy, we have now the work done by the gas on our second method to be 8,600 joules. So in our problem, a temperature of 3 molecules of monoatomic ideal gas, which is reduced in its initial temperature to its final temperature, we now have the change in internal energy to be negative 7,100 joules. This is negative because the work is done. The work is done by the system. While for our work done by the gas, we have at 12,600 joules for our first method, and we have 8,600 joules for our second method. That's all, and thank you for watching. See you!